All right. Good afternoon, everyone. My name is Mike Baranowski. I'm the moderator for these afternoon sessions. First up, we're going to have Ryan Lavery from Dewberry, and he's going to be presenting on the North Carolina Statewide Lidar and AI.
Good afternoon, everyone. My name is Ryan Lavery. I'm a senior geospatial analyst with Dewberry, based out of our Charlotte office. One fun cultural geography fact about me is I lived in Winston-Salem for a few years when I was a kid, and this is where I learned how to ride a bike. But now back to what we're here to discuss. Today I'll be speaking about the North Carolina Lidar program, also known as the North Carolina Floodplain Mapping Program, or NCFMP, and the potential for different semi-automated LiDAR classification approaches and prospective machine learning classification enhancements. While there is and ever will be an increasing level of automation, there still will always be a component of manual review and preparation necessary for these projects. A little bit about Dewberry before jumping into that. Very brief overview. We are an AEC firm with geospatial and survey segments that is based out of Fairfax, Virginia, with over 2,500 employees, 60 locations nationwide, 2 of which are located in North Carolina, 1 in Charlotte and 1 in Raleigh. So this is a basic overview of where the state and temporal aspect of the LiDAR available in North Carolina stands. The 2024 is already in the state's hands, and it's in the middle of the QC process. And to the west, the 2025 collection is actively ongoing and being processed, which will be delivered to the state by the end of this year, and then the process of QC will begin. As most of you probably know, North Carolina really does have one of the best, if not the best, statewide LiDAR programs in the country. Not to beat a dead horse, but this also follows suit with the state's robust GIS and orthoimagery offerings as well. Some other comparable states are Connecticut, Florida, Virginia, Louisiana, Missouri, and Indiana. The only reason why I mention that is something to think about depending on if you are a vendor or if you work within the government, other states where you could possibly reach out to your counterparts and bounce ideas off, kind of like some of the discussion at the lunch panel was speaking about. This map shows that all of the data is QL1. And for those who aren't super familiar with the quality levels of LiDAR, typically most of what you'll see being collected now is QL1. There is a lot of QL2 data that's available throughout the country. QL0 is the big difference between that and QL1 is the accuracy standard. The points per square meter is the same, but due to the accuracy standard, it typically ends up being denser than the 8 points per square meter. North Carolina specifically has the spec for the 9.25 centimeter RMSE. And this is just a visual example of some of the final deliverable products in a hydrographic area in North Carolina. These are the counties that are included in the 2024 collection. North Carolina's program is also one of the first nationally and was a result of Hurricane Floyd back in 1999. With this year's collection, the state will be, or with 2024's collection, the state is fairly close to being collected 3 times over. After the 2025, the entire state will have been collected 3 times with increasing quality each collection cycle. The 2004 collection covers over 10,000 square miles and spans 19 counties. The general project of the LiDAR program is very critical with the influx of population and development occurring, along with planning for ongoing and any future disaster recovery. It's also been skillfully communicated throughout this conference how important and crucial this spatial information is for documenting and funding after these disasters and other scenarios. This is the region that Dewberry collected in the 2024 collect. As has been mentioned in some of the other presentations, counties buying up additional deliverables that the state did not request. Chatham County is an example of that. Just kind of showing like proof of concept or an example of that. These are the counties that are going to be collected with the 2025 cycle. It'll cover most of phase 4 and phase 5, and at a minimum, the entire state's going to have 8 points per square meter. And specifically for this AOI, it covers the majority of the counties that are most greatly impacted by Helene and have ongoing recovery efforts that will remain for years to come. This is also the area that Dewberry is collecting for this phase 5 refresh. Now that the state will have QL1 entirely, I've pondered what other enhanced products and analysis could be provided from this improved data. Are we, as the geospatial and GIS community, using the LiDAR data sets to the full potential? How could we improve classifications in North Carolina on future collections? This is just a quick look visual from 2024. It's at UNC Chapel Hill's campus. You can see the football stadium, soccer field, and baseball field. Just to get kind of more of an idea for those who aren't very familiar with LiDAR, what the raw point cloud looks like. This is also Chapel Hill, a DM showing the hill of Chapel Hill. But a basic overview of what this presentation is going to cover is the current aerial LiDAR classification process, machine learning processes, AI versus machine learning, and software available and machine learning capabilities. Here's just a few more visuals to continue to get an idea of what you're able to see with LiDAR data. This includes Dorton Arena, Frankie's Fun Park, and North Carolina State University's Carter Finley, as well as Raleigh-Durham International. You can see the variations of planes, vehicles, trees, all the above ground features. And to the right is North Carolina Central University's track and field. You can notice the NCCU logo is visible, but also people actively on the field, practicing, and so forth. So for the current classification methodology, using tear scan algorithms for geometric-based LiDAR classification, utilizing planes, terrain angles, and iteration angles, as well as pseudo-segmentation, meaning that tear scan uses a methodology called grouping that segments out points, but it's not exactly machine learning because the data set isn't training the process that is doing the classification. At this point in time, I have yet to find another software or processing approach for grounding aerial topographic LiDAR that meets the quality level and efficiency of tear scan. That being said, things change constantly, and there might be a point in time where there is some other method that is quicker and more accurate and efficient to use. TerraScan's been around for 25 plus years in classifying point clouds. It includes a robust set of automated classification tools using a combination of LAS attributes, terrain angles, processing, iterative distance processing, and segmentation. They release new tools fairly regularly, sometimes a few times a month, sometimes once a month. But they also have a very responsive technical support group that is very receptive. Here's an example of tinned raw grounded data and then the derivative half-foot DEM from that point cloud. A little more explanation on the geometric classification side of things. It utilizes spatial information and attributes stored within each point of a point cloud in reference to the other surrounding points to delineate and classify points based on the mathematical parameters of a given classification routine. In shorter terms, a variety of triangulation measurements and degrees of iteration are used to classify the points. With this classification approach, there are multiple variations of what desired features can be classified. Initially, this is typically going to be the ground surface, so you have a base area to begin basing the classification of the other points. But some projects, the ground isn't as important, so utility lines or vegetation in structures is more so the focus. And now on to artificial intelligence and machine learning. Artificial intelligence is kind of the parent, so to speak, but it's the broader set of computer systems that can perform complex tasks that historically only humans could do and take multiple or many manual hours. Machine learning is a subsection of artificial intelligence that performs self-learning computational algorithms, either supervised learning tasks or unsupervised learning tasks. Semantic segmentation of LiDAR point clouds is the method of LiDAR classification that differs from the geometric approach because it's analyzing specific characteristics of neighboring points to then delineate between different points of what the feature type is. LiDAR segmentation is, the goal of LiDAR segmentation is to spatially group points with similar properties. It can be trained with models, allows for recognition of points that belong to the same real-world element, such as trees and buildings in these examples. And it continuously will classify point labels to groups of points to build upon the base. Some different softwares that have machine learning, and I'm going to cover a few. There are more out there, as well as AI approaches, but these are just some that I have worked with and tested. But ArcGIS Pro allows for statistical machine learning classification methods. There are deep learning methods, deep learning options also available, and there's a robust set of trained models. It's not a default thing. You have to add or install the deep learning libraries. The processing speed results also depend on the data set you're working with and what systems you're running the processes on. Currently, this does seem to be more geared towards imagery as opposed to LiDAR, but there are machine learning LiDAR classification approaches within ArcGIS Pro. There's also Global Mapper. It's great for data conversions. The LiDAR tools greatly improve each update that they have. It also offers segmentation based on spatial and attribute relations. It's easy to use interface is useful for users to be able to work with the data smoothly. The processing speed is improving with batch scripting, but there is definitely room for it to increase, and I'm sure it will in the future. There are also open source options, just so it's not all paid license type of software to go over. But those are some different examples. There are R models and Python packages for LiDAR segmentation. These are some example derivative GIS products that machine learning could aid in increasing the speed at which they're created and then delivered to the end user client. This is an example, another example of the half meter DEMS as opposed to half-foot DEMS. There are also true vegetation layers. .3D building polygons, LOD2. Walls, fences, man-made objects, power lines, poles, cars, basically anything that there's a point return on, there is potential for classifying it. Also, danger tree encroachment for utility lines, land cover layers, asset management and asset management if the point cloud is dense enough. So what are some pros and cons to think about with machine learning? Project specifications always need to be considered to decide what the most efficient and accurate method of providing high quality data to meet the standards and desired deliverable by project type. At the end of the day, you always want to make sure you are producing something that is accurate and high quality. The schedule of a project also needs to be assessed regarding the chosen approach. You have to account for the processing time that the equipment or whatever software and computers you're using, how fast it will process through the data, but also if you have a lot of projects overlapping, what the amount of processing time you have available is, and then also the manual component of actually implementing it and then doing the quality control of a project. And lastly, accounting for costs related to software and the equipment that you're using, as well as making sure the data stays secured. And again, manual labor, because there will always need to be a manual component. So some questions and to pose to the GIS community are that is TerraScan still the standard, industry standard, but we can enhance NC LiDAR with above ground classifications utilizing machine learning processes? Would it be worth running enhanced classifications on old data sets that are already existing? Therefore, you don't have to go through the process of acquiring it, processing, also paying for it, depending on who the end user is. What are the most sought after derivative products that are not currently available? What are different needs that government agencies, municipalities, and counties might encounter? How to communicate with and hear back from constituents on what type of products would be most beneficial and help communities. Would releasing surveys be something beneficial? Also, ways of building awareness and interest in younger generations for anything geospatial or GIS related, and how to reach out more so it's a field that people are more aware exists. And how best to work with leaders, vendors, and communities on what data is important and what is needed from this great existing asset that North Carolina has. And these are some sources included. Does anybody have any questions? I think I have some time. Yeah, so the question was, do we use Global Mapper for stitching together data sets with a temporal difference, essentially? Typically don't use Global Mapper. We usually use TerraScan, at least on the classification side of things. But yes, there are issues sometimes if you're using older data or data that's from another state, let's say, because depending on the quality level of it and also the temporal aspect, like there could be snow or could have been leaf off for one and not necessarily leaf off for the other. So that's something that also kind of causes issues in the calibration side of things too. But usually you can offset to, especially if you have a data set that you've already ground truthed and included the accuracy assessment of the survey, you can figure out a way to kind of blend it together, so to speak.
I'm interested in the question you posed about how to communicate with constituents about their data needs. That's something that I've been thinking about a lot as well. I was wondering if you have any thoughts on how to do that, what would be best, what are best practices?
I mean, the question was how to communicate with constituents best, potentially. I mean, I think, so I live in Charlotte, and I'm GIS, geospatial nerd, so they have lots of emails that you can kind of get on. So they'll send out like daily or weekly emails, and they'll send out questionnaires. And sometimes they use social media also. I think those would be some good ways. Telling anyone you know about it when you get a chance without boring them to death, depending on what you're talking about, could be some other ideas. Or maybe, I mean, I think going to like universities or even like high schools and middle schools and having like a GIS day there might be a way at least to get like younger people involved. Because honestly didn't really know that much about GIS until I got to college. I wasn't aware that that was like a field or anything like that. So I think the younger people are when they learn about it, that could kind of like plant the seed, I guess, so to speak, in their head and go from there.
I have a question for you, sorry.
Yeah, you're good.
For the AI and machine learning stuff that you guys are doing, are you feeding that a ground classified data set and letting it go from there? Or are you giving it just a raw point cloud?
We've tested both with varying degrees of success depending on the data set and what the terrain and topography and above ground features are like. So both, I guess, if that answers your question.
Is there one that's more effective or tends to work better than the other?
If it's grounded already, it does seem to work more efficiently and accurately just because there's already that base set to work off of. Yeah.
I just, back on the subject she was talking about in terms of what is it that the public is looking for.
Mhm.
I'll say, I'm an elected official in Orange County, North Carolina, and I, with some frequency, hear from people in Orange County who are interested in being able to look at LiDAR data for Orange County. And the problem is that they're asking me, how do I actually do that? And I'm like, well,
Yeah.
let me give you an hour and a half long presentation on
Yeah.
how to do this. And so the barriers to entry for people not like us in this room are very high. And I think that I don't know if it would be how feasible it would be, but I believe there are other jurisdictions, other states that have created a sort of web viewer of
Mhm.
a simple web viewer of LiDAR data that allows the general public access to this data in a way that
Yeah. Yeah, that would.
practically possibly. So that's
Or-
just a comment.
Yeah. So the comment was there's some counties and municipalities that have created easy to use web viewers as another idea of ways to get the word out, essentially. But yeah, it's good. It's a good thought.
I think NC1 map has a viewer for existing LiDAR data.
And definitely, that could be something too. Just even promoting NC1 map and everything that the state already has available that is ease of access.
Just a comment for his question. I think there is a USGS.
There is, yeah. Yeah, and there's also the USGS 3-dep tool. Yeah. Yeah.
Just to add to another tool,
Yep.
there's like a mid-layer one for somebody that kind of likes GIS but doesn't have, GIS Pro. There's an add-on you can get for Google Earth Pro that has LiDAR for the whole country. So I think, at least, it's a topo, and I'm pretty sure it's free. So I don't remember what it's called, but if you look
Yeah.
for it, you can probably find it. I think it's put on by the University of California or Cornell, one of those. Their geospatial. So.
Thanks. All right. Thank you, everyone.